afternoon, everyone. Welcome back, and thank you for being on time. Now, for this whole seminar, we are just left with two more papers. Seismic performance of a step-back medium-rise RCC building with combined vertical and geometric irregularities and improved occupational health and safety. These are the only two papers we are left with, and for this, the last moderator for this whole seminar, I'd like to introduce. He is the Chief Urban Planner under Ministry of Works and Human Settlement. He has Bachelor of Architecture and Masters of Urban Design and Development. He has decades of experience in urban planning and in architectural field. He served as architect in Ministry of Works and Human Settlement from 2002 to 2010 and worked on national projects such as VVIP Gallery and Stadium in Changmyang. He also served as a Chief Urban Planner till July 2019 in MOWHS. He was also project manager for National Development Plan called Comprehensive National Development Plan for Bhutan 2030. Now may I invite Mr. Chado Dukpa on stage to guide us through the remaining session. Thank you.
Good afternoon. On behalf of the presenters of the session and on my own behalf, I would like to welcome everybody, especially Chief of JICA, officials from JICA, CEO, and all distinguished guests here. I hope the interest that this session generates would keep all of you awake. I can understand this is after lunch and definitely there can be a lot of tension between wanting to sleep and listen to this important presentation. For this session, of course, MC has spelled out some of the basic things, but I would like to reiterate a few important things so that everything goes as per the plan. For this session, we have actually two sections. The first part of the presentations. Initially, we had 3 presenters, but now it has been narrowed down to 2. So we have 2 presentations, and then we have discussion towards the last part of the presentations. For presentations, I have been told that despite one member being removed, the time allocated to each presentation will be same. So you have to stick to your presentation within 15 minutes. And I think in the course of presentation, you might have a lot of questions, which I would request all of you to note it down so that we'll put it up later towards the section where we have dedicated time for questions and answers. While the time for each presentation will be 15 minutes, I was told that the overall time that was allocated to us was about 1 hour 20 minutes. That will remain the same. So which means we are going to have more time for question and answer. That is the understanding I have been given. But what we also have to keep in mind is that we have subsequent activities. So therefore, if you can finish within the given time, it's far better, Sessionila. With this, I would like to take this opportunity to introduce as well as welcome the presenters to the stage. First of all, I would like to request Mr. Sange to come on the stage, please. So a brief on him. Of course, the briefing is more going to be verifying whether he is the real person as printed here. So Sange Palden actually works in BPC. He has a Bachelor of Engineering, Bachelor of Civil Engineering, and he has Masters in Technology in Structural Engineering. So this is Sange, and he's going to present, which I will let you know later. And I would also like to take opportunity to welcome Mr. Krishna to the stage. So Mr. Krishna Subba is working as a Deputy Chief Program Officer at JICA. He has a bachelor's degree in mechanical engineering, and he has MBA as his master's. So with this, of course, how the session is going to happen, I've already briefed. So without further ado, I would like to request Sange to start with the presentation. I think I don't need to say what the presentation is all about. So Sange, you have 15 minutes, which will start. The stage is yours.
Thank you, moderator. Honorable CEO, CTCL, the Chief of JICA, distinguished guests, my dear brothers and sisters. Yesterday and this morning, we had a discussion on how to replace RCC buildings with ramped earth buildings and also with timber as a structural member. And here I'm going to present again on how to use RCC buildings in a little better way than how we have been using till now. The topic is on seismic performance of a step-back medium-rise RCC building with combined vertical and horizontal irregularities. Step-back buildings means the those buildings with varying base levels, especially in our sloping terrain in mountainous regions like in our country. As far as structural view is concerned, our building should be very regular, symmetric. If you want to keep away the complexities of the structural dynamics, the building should be very regular, symmetric. But in this case, I have, due to our geographic terrain and all, because of our terrain, these irregularities become unavoidable. I think this topic is relevant for Bhutan. The figure on the right-hand side is a global seismic hazard map. It shows about the seismic hazard. If we see at the end of the arrow, we will see that Bhutan is located towards the end of that arrow. And if we zoom in, Bhutan. This is the figure on the right is the seismic zone of India, showing Bhutan surrounded by areas located in zone 5 and 4. And zone 5 is the most critical, the most critical seismic area, seismic prone zone, as per the seismic zone of India. And before I go to the next slide, about the seismic earthquake engineering in Bhutan, as of October 2010, we do not have a seismic hazard map for Bhutan. However, studies are going on. As of October 2018, we have around 14 seismic intensity monitoring stations installed in our country, and we have around 20 intensity earthquake intensity measuring stations. And as per the study conducted by the Department of Geology and Mines, they have come to the conclusion that in Bhutan there is a seismic gap and there is a risk of occurring seismic with a magnitude greater than 8. Therefore, I felt that whatever building design method that we have been adopting till now is quite not up to the standard. I will take you through the earthquake destruction in history in Bhutan that occurred in September 21, 2009. The epicenter was in Narang in Mongol. There was a loss of destruction had taken place. 11 people were killed and economic loss of $45 million have been incurred to Bhutan. And on the right hand side, the tallest RCC, as far as I know, that is the tallest RCC structures in Bhutan, and it is located in Khonsaling. And if you want to know the designer, it was designed by a foreigner from Taiwan, structural engineer from Taiwan. So I think that we, as an engineer, we have lots of scope. So if we require the Taiwanese people to design a 9-story building, so we can imagine what is the status of our engineering background in Bhutan. We are talking about how to design our building which is resistant to earthquake. And about the rapid urbanization trend in Bhutan, that one, the one in the green area, is in Thimphu in 2005. 7 years later, in 2012, you can see the concrete jungles have sprung up here. In 2018, you can see that buildings are climbing up the hill, and that is where I was interested. I think that the flat lowland areas were used by our seniors. They said that they were lucky, but as the urbanization trend kept on growing, the buildings have to take place, such like the one in the right hand side. When buildings are located in such places, we have foundation levels at different level, so that makes the building very irregular. When we do the seismic design, there is it can be categorized into two subheadings: static and dynamic. Static is something that doesn't change with time. Dynamic is something that changes with time. And under static, we have equivalent linear static method, equivalent static method. That is the mostly used method for the seismic design. And under same, we have pushover analysis. That's for non-linear. And under dynamic head, we have again linear and non-linear. But mostly used, the practice that we are adopting till now is equivalent static method, mostly used in the courts. I will tell you the details of how it is being done. And if you look at the graph below, linear is in the area located in the red circle. And when we are interested in the linear method, we are not. If we draw the stress strain curve for any material, we will see that the typical stress strain graph is like that. But when we are within the linear method, we are just concerned about in the elastic region. We are afraid, or we are not capable of going to the elastic region, which is marked in the green area. However, that linear method is the most simplified method, and better than that, we consider the dynamic method. That is also within the linear range only, but that is a little better. So I wanted to propose that it's not I, but the code dictates that we have to conduct dynamic analysis. In the next slides, we have seismic code IS 1893 2002. As per that code, we have the leniency of conducting a static method, conventional static method for buildings. If it differs with the range seismic zone. For seismic zone 2 and 3, that static method was valid for buildings less than 30 meters in seismic zone 2 and 3. But in case of 4 and 5, no, I mean like in buildings in seismic zone 5, buildings greater than less than 30 meters, we can apply the static method. And for regular building, I mean that also. And for seismic zone 2 and 3, that static method can be applied for buildings up to 90 meters. And for irregular buildings, in seismic zone 2 and 3, we can use that static method up to 30 meters. Whereas if the building is higher than 12 meters, it dictates that dynamic analysis has to be performed. Whereas in the revised 2000 IS 2016, it says that even vertical earthquake load has to be considered if the structure is located in seismic zone 4 and 5, and Bhutan is surrounded by seismic zone 4 and 5. And this same code, revised code, latest one, it says that equivalent static method can be only applied for building with period less than 0.4 seconds. And also, the same code says equivalent static method shall be applicable for regular buildings with height less than 15 meters in seismic zone 2. So this clearly says that in Bhutan, whatever the height the building may be, we have to perform the dynamic analysis. But as far as I know, dynamic analysis are rarely performed by the designers in Bhutan. To give the rough idea for the equivalent static method, that is the simplest method. How we go about is that we find the seismic horizontal coefficient that is given by AH. The formula is given right there. We just need to know the zone factor, importance factor, and the response reduction factor depending upon the ductility of that member, and SA by G. And W is the seismic wave.
Sange, you have 4 minutes.
And equivalent static methods, we just consider we lump all the seismic mass and then we give the horizontal base at the base, and then we distribute the lateral load as a function of the story height given by that formula. And it only considers first mode of oscillation. Only like the building will rotate to the right side, just one mode. In case of response spectrum method, that is a linear static method, it is a superposition of multiple modes of oscillation. Here we consider that building will have multiple modes when they are oscillating under the earthquake loading, ground motion. The building will rotate and deflect in a various mode, and we combine this seismic response through a formula. There are many methods to combine. Like these are the formulas, like A, B, C, lambda A, lambda B. Sometimes they use some of the square root of the squares, complete quadratic method, then absolute sum method. And response spectrum method also considers whether what percentage of the seismic mass is participating in that oscillation. And as per the code, when we perform the dynamic analysis, we must ensure that only 90% of the seismic mass should oscillate during the seismic loading. So we can have multiple modes considered, and then we get the true dynamics of the structure. And in my study, I have relevant codes. Those are the codes, and these are the building details that I have used for the analysis and design and analysis of the building. These are the column details, and these are the models. In my model, first I have considered the reference model as the building with the 6-story height and 3 meters height, 3 meter story height. And for the model 1, I have put a discontinuous shear wall at the base. For the model 2, I have kept the story height, the base of the story to 6 meters to include the soft story effect. And for the model 3, I have just kept the foundation level at different level, suiting to our topography of the land. And in the model, fourth model, I have varied the foundation level and also kept the discontinuous shear wall at the base. This is usually in Bhutan, it is being used like that without properly understanding the dynamics, how it affects the structural dynamics. And what I have concluded is that based on the fundamental templates, the RM is this reference model, M1, M2 model, different models. And from the models, we can see that the model M2 models with soft story in the basement floor has the highest story, and we can see the temperatures are more than 1.5. So static method was not relevant here. As per the code, if the temperature is more than 0.4 seconds, we have to perform the dynamic analysis. But in Bhutan, irrespective of the temperatures of the structure or whatever, we just perform the static method, that is equivalent static method, and then we design and we draft and we produce the drafting and detailing of the drawings. And this is the story displacement from equivalent static method and response spectrum method. In X and Y, we can see that in Y direction, that which one is in red, the story displacement through equivalent static method is quite higher than the one which is produced by response spectrum.
Sanjay, how many slides do you have? More?
5 more.
So can you do it in 2 minutes? Maybe I'll extend the time by about 2 minutes, because I think this is quite technical, and maybe the better parts are coming in the later part of the study.
These are the
How many? I can give you 2 minutes more. 2 minutes. Try to hurry up.
And then I have compared the responses of different models of the building in terms of temperate, moral shear, story displacement, and story drift. And as we can see from the graph, we can see that the one which is given by static method is quite higher than the one which is given by the response spectrum method. That one is in response spectrum in Y direction. And this is the comparison of base shear. If we see in model 2, the base shear is quite less. And however here, if we compare to the temperate for M2 model is quite high, but when it comes to base shear, basher is quite less. Here, if the temperature of the structure is less, then it will attract high basher. The conclusion is like that. And as per the code, we must, when we perform the dynamic analysis, we must ensure that 90% of the seismic mass is participated for the calculation of the responses. And here, if we look at the M4 model with a combined discontinuous shear wall and basis at various level, we can see that in both X and Y direction, it is almost less than around 65 or 80, which is not like 100%. So from this conclusion, from this study, what I wanted to conclude is that equivalent stacking method gives unreliable seismic responses. Building with soft story in the basement floor undergoes maximum displacement. I think this is we must look into, because there is a clause. There is a regulation from the THOMDE that our base of the story must be kept for parking. And if we do not perform dynamic analysis, I think during the time of earthquake events, our building may not be resistant to earthquake. And step-back features from varying foundation level changes the structural dynamics of our structure. Dynamic analysis must be performed for buildings in hill slope, especially when the building foundation is at various level. Our dependence on equivalent static method is not okay. So we have to perform dynamic analysis. And I have performed analysis in ETAP software, and considering damping ratio for 5%, which is allowable as per the IS codes. And
I think that's it.
Yes.
Okay, thank you, Sanjay. A very interesting presentation. Of course, there are a lot of elements of technicalities where I think for me as an architect, I was rather interested towards the last part of the presentation, what the recommendations are. In a nutshell, actually addressed to me, the presentation was about aesthetics, ground conditions, environmental requirements versus structural challenges. So I think I'm very sure you must have a lot of questions based on that, which we came on to a later part of the presentation. Thank you, Sanjay. And with this, I would like to request Mr. Krishna Subba to kindly make the presentation. 15 minutes, of course, now you know that it can be extended up to 3 minutes, so but if you can do within 15 minutes, that will be better.
Thank you, moderator. Good afternoon, Dasho's Chief Representative, distinguished guests, and faculty from CST and colleagues. Good afternoon. I'll straight delve into my presentation. Basically, it's learning on the improving of OHS and key learnings from the Japan and the Japanese ODA projects around the globe. So outline is just, I'll introduce OHS and the status of OHS in Japan, similarly in the Japanese ODA projects, and just briefly touch on the hazards and risk, and focus on the managerial tools to actually improve safety in workplace, followed by challenges that we face in Bhutan, and conclude with few conclusions there. And now, why is OHS so important, the occupational health and safety? First of all, as you all know, that being in a workplace and with hazards, there is no such thing as a risk-free environment. And the downside risks of accidents in a workplace are huge, not only to the individual, but to the company, his or her families, both in terms of mentally, physically, and financially. And of course, many of the industrialists have also stated that the importance of safety management is actually directly relates to the safety quality. So if your safety is good, it will reflect on your quality. And globally, we can see that almost 6,000 workers are affected by accidents in the workplace. In in close to home, let's say in India, it's estimated that about 48,000 workers are affected annually by construction accidents, out of which 25%, or almost 12,000 people, pass away as a result of the construction accidents. And in the developing countries, it's estimated that they are exposed to 4 more hazard than in developed countries. So now focusing on the status of OHS in Japan, as you all know that after the Second World War, for 3 to 4 decades, Japan had a rapid booming economy. It grew almost 10% GDP annually, which led to increased constructions. That meant that there was increased construction accidents and fatalities over the years. In a year, the construction accidents and fatalities attributed to almost over 6,000 workers in the workplace. However, after 1972, as you can see, there's a steep decline in the graph on the right-hand graph. I'm sorry for the small fonts. It's basically due to the implementation of the Industrial Safety and Health Act, which was instituted by the government of Japan. As a result of which, within a span of 5 years, the fatality generally decreased by almost 50% across all industries and even in construction as well. Now, this is the latest status of the OHS in Japan. As you can see, it has improved considerably. I think one of the main attributes is to the policy and academic interventions by the government of Japan. In 1978, the University of Occupational and Environment Health focused on improving the rate of worker fatalities through academy and research. Similarly, the Japan International Center for Occupational Safety and Health and the Japan Industrial Safety and Health Association have been formulated, where they have taken up proactive measures to actually promulgate this culture of safety in organizations. Actually, I'm sure you would have heard phrases like safety first, which translates to Anjin Daichi in Japanese. They are the ones who've actually taken it to the ground. So now coming into JICA, just briefly touch on the thing that, as you all know, that JICA is the OD implementing agency of the government of Japan, and on the right you can see the pie chart. We across the globe, this is 2017 figure, that we have about 2,621 million and in grant aid, about 280,000 in technical cooperation, and about 2,500 million in ODA loans. This is just to give you a summary. And JICA really focused on the safety, especially in the construction industry, after 2007, when there was one of the worst accidents in the history of JICA, where 54 workers lost their lives in the construction of the Can Tho Bridge in Vietnam. After that, safety has been accorded a top priority in the construction work. And now JICA regards it has an important role to establish and to disseminate the culture of safety to all the stakeholders involved in the execution of ODA construction work. And I'll not read the rest, but these are some of the methods as how they do it. This is the status of the accidents and fatalities in JICA ODA projects. As you can see, the blue line, which represents the loan, and then the red one represents the grant, which are more construction intensive, attribute to most of the fatalities and accidents. On an average, there's about 25 fatalities on a year, and about 25 accidents cases are reported across all JICA projects from the globe. That's talking about 50 to 80 sites from around the globe. Now, I just focus on one of the key aspects is the safety plan. It may, for many of us, especially in the Vietnamese context, that it may just be a document, but for JICA, it's one of the main tools for implementing the improvement of OHS. Detailed safety plan outlining the procedures, rules, regulations will be put in place to protect the workers and preventing accidents. As you can see, and the safety plan is actually implemented right from is made alive right across all the phases of the procurement stage. Even during the tendering stage, the tenderer is required to submit a safety plan where the consultants and the employers will give feedbacks and then submit it back to the tenderer, and where is supposed to include those aspects into his submission. And finally, during the contract stage, the similar process is followed, and actually is more vigorously done so during the implementation of the contract. Now it's coming into hazards and risks. I'm sure sometimes we use this term quite interchangeably, but hazards is basically a potential source of harm, and risk is basically a likelihood that someone will get injured coming into as a result of that hazard. So there are 5 types of hazard control methods generally. The elimination, where we physically remove the hazard; substitute is to replace the hazard; and engineering control is to protect or isolate the people from those hazards; and administrative control is we change the way the people work. And then finally, the personal protective equipment. Generally, it's said that the most effective is elimination and the least effective is the PPE method. But of course, you have to consider the cost aspects as well into it. And now, just want to highlight on this, contrary to most of the conception, the Japanese ODA projects have actually found, and they express that the methods, the key methods to improve occupational safety do not actually require additional, so much of substantial additional cost, where we focus on most of the administrative and managerial aspects. Of course, engineering costs are very cost intensive. So I just want to focus. So my main focus will be on those administrative costs, which may or may not, maybe are least cost intensive to the organization. So they are like the methodology of 5S, enhancing the workers' awareness, and then setting up appropriate safety facilities, and the PDCA cycle, of course. And I'm sure most of us are aware of 5S, but however, just to iterate, they are derived from the Japanese words of sort, set, shine, standardize, and sustain. Setting is basically organizing the setting is to remove the unnecessary things from the work site so that the workplace can be used effectively. And setting is organizing the necessary tools and materials in an orderly manner. And shining is, of course, keeping the work area properly and thoroughly clean. And standardize means enforcing the methodology of sort as rules to be followed. And finally, sustaining those 4 activities as part of 5S for daily work and maintaining it. And the other aspect is the enhancing workers' awareness. Many of the organizations have very good safety rules and management practices in place, but however, the workers are not made aware of it, and sometimes even the managerial level may not be aware of the various implications of the lack of enforcing such rules. So one of the things is that we need to make sure that everybody sets the rules and follows them. And hazard prediction activities. This is one of the major activities that are undertaken in all JICA ODA projects. They gather 15 minutes before the actual scheduled time for work in the morning, and then they just sort of go through the plan of the day, and then they try to identify what are the possible sources of hazards and risks in their activity which will follow in the day, and they try to overcome that hazard. And finally, I'm sure you would have heard of the Heinrichs model, where the 300:29:1, where it says that in a workplace, for every one serious accident, there will be 29 minor accidents, which would have a near miss of 300. So basically, the accident reduction is a proactive approach to actually immediately identifying as soon as you have a near miss. So basically, you report it to somebody, and then they will take measures to ensure that the hazards and the accident risks are overcome, or they address it properly. So basically, so when you reduce the 300, you reduce the 28, and thereby you try to reduce the serious accident. So that's the whole rationale. And of course, this is simple, but setting up appropriate safety facilities is. I just read over it. Is prepare appropriate work platform in high place, and then properly fixing of stage boards, placing guardrails around the work area, and posting flagmen for slinging or heavy machinery work. Yeah. So
Krishna, you have less than 3 minutes.
Okay. Thanks. Yeah. And so that's the one. And finally, the PDCA cycle. PDCA cycle is constantly is a tool to actually continuously improve your safety management plan. So basically, after the safety management plan is adopted and then implemented, there is a need to constantly routine and periodically check those things, whether it's been followed or not, and what were the shortcomings in those plans, and how to integrate it into the revised safety plan. So this is the thing of PDCA. So just want to highlight the challenges. As you can see, in Bhutan, there was 90 recorded accidents and 33 fatalities. And construction industry again tops the list, where we have 20 accidents and 27 fatalities. Now this is really, I verified this figure again, whether it's 20 accidents and 27 fatalities. I was really surprised, because usually in other countries we have higher number of accidents and lesser fatalities, right? So, but because I think it's because, and also it's pointed out by the World Bank report, that we fail to report accidents. So that's why it leads to a lack of data. And the other thing is that non-compliance by the workers to use PPE. Many of the Bhutanese companies actually provide PPEs to the workers, but they don't use it, or even if they use it, they don't use it properly. And inadequate education and awareness of health and safety issues, I've already highlighted that. And unwillingness of Bhutanese companies, not all, to invest in long-term OHS improvement, except CDCL and some private companies. I know CDCL has done excellent in terms of integrating OHS plan, and then setting up a safety unit, dedicated safety officers, as well as providing insurance and PPE to the workers. So, and also the Department of Labor is actually responsible for enforcing the OHS Act. But however, due to the limited capacity and human resource, they cannot enforce and oversee all the sites in Bhutan. So finally, conclusion, I just want to conclude with that to improve, maybe we need to, of course, the OHS policy is already in place, safety, but now we need to make sure that each organization makes it a dynamic one, and accountability of safety officers and safety committees. So basically, it is the safety officers should be made accountable. I'm sorry if Sonam is here, but I think yes, because it's your responsibility to actually make sure that all the workers are aware of the safety regulations. And similarly, the partnerships and involvement of academia and independent organizations. This has been highlighted over the course of the seminar. So we're learning from the experience of Japan, they can do risk assessment, increase awareness, OHS education, and safety campaigns. And finally, including the aspect of safety into the contract as one of the items for implementation with set of standard safety requirements. I hope that's it. Thank you so much for it. Thank you.
Thank you, Krishna. So we are on the second part of the session. It's going to be Q&A. Like I said, we have about, if we are to keep within the time as allotted, we're going to have about altogether 50 minutes. But like I said, to make sure that there's enough time for the subsequent activities, I thought maybe we should conclude the session by 3. That's how it should be said. So, on Krishna's presentation, it's very important, and I have few catchwords to mention so that it can spark imaginations, your question, and so on. The experience for Japan is to say that if you initiate or do something, improvement can happen. That's what it has been shown. But there's something very paradoxical thing happening about construction sector. Somebody is working so hard for the life, but he or she doesn't want to care much about this. This is something paradox happening, but there are good recommendations given. And of course, like Krishna was saying, if there is good awareness, if there's education, if there's good regulations, I think we can do it. So with this note, I would like to open the floor for Q&A. So the floor is yours. You can have questions.
Thank you, moderator. I couldn't resist making some comment because these are two very important topics, very close to my heart and very close to what CDCL is doing now. I'll go backwards. First, I don't have any question, but I just wanted to add a few more points to what Krishna has presented, so that our down the line, our colleagues in the audience will have some question. Now, the most important thing about safety is, I think this is a very, very critical missing link in the Bhutanese industry. And through CDCL's experience in the last, you can say 8 or 9 years, we did 2 occupational health and safety seminar organized by JICA and the Department of Roads in the past. And from our own experience, I think, as I said earlier, this is a really critically missing link. And if you look on our own policies and adventure and experience in the construction industry, I think if we are, this is my personal belief, if we are able to set a very, very professional benchmark in the OHS, in the construction industry, this will certainly make the workplace and the blue-collar sector very attractive to attract our young colleagues. And as rightly pointed out by Krishna, I think there's a lot of unwillingness within our own construction industry to invest in the long-term OHS improvement. But there are also other facts that we need to know. One is that from our own experience, I think if you look at any projects, we have also international colleagues here, we know that there are 3 major components in any project, and that is the in terms of cost, the material component, the equipment cost component, and the manpower component. What is missing in our industry is the OHS component. And in the past, when JICA organized a seminar, this very question I asked to some of the top-notch companies, representative from Japan, and I think in their scheme of things, they always keep up to 5% depending on the project size on OHS, whereas this is non-existent in Bhutan. And one of the reasons, if you don't project this in the cost estimate, how can the contractors inject that? And I think as far as the World Bank and ADB projects are concerned, these items of work are already nomenclatured in the form of a BOQ. So this is something seriously we need to think, Mr. Shunila. The other thing I thought was that also from our own CDCL experience, I think we certainly need to make compliance and monitoring very strict. And I think we should start from there. Again, inherently, while we have the policies and legislation in the right place, I think the hardcore human resource is missing, Shuni. And I think where there is will, there is way. But certainly, I hope in the long run, if you want to change the scenario in terms of employment, this is certainly, that is what we need to do. As far as CDCL is concerned, I think we are actually trying our best, giving our best shot. We are collaborating with agencies like JICA, and we are sending our people to very experienced companies from Japan like DNC to get a feel of how they manage and then do things related to OHS. And our people have come back. We are implementing this on our sites actually. And I think basic thing first, if you look at the construction industry, the basic amount of insurance itself is not done actually. And while we don't get paid in CDCL, but we have made sure close to about 700-800 people are already insured in CDCL, right from myself. So these are some of the basic things that would make difference. The other one on the structural presentation, I was really impressed by what Sanjay presented here. And I think I won't go to bridges, but I think to building, this is something probably, has sparked a lot of debate in the mind of many people. A place like Thimphu, I think the last time I went to Thimphu Thomde, they were saying they have over 700 permits, building permits going on at the moment, multi-story building. And one of the given fact, whether we take it lightly or heavily, is that there's a huge limitation of structural engineers in the country. And I think the concept that we do in terms of structural design is the strong column and weak beam concept in terms of seismic resilience. My personal belief, and quite often as an engineer when I discuss with others, is that the architects do the design, and when it comes back to structural engineering, basic elements related to the data are missing. I think on all this project, there's hardly any geotech survey being done, like SPT or soil or load test. And I think there's a basic assumption, and I think this is totally wrong. We are in a terrain, as Sanjay pointed out, entire hill has to cut down. So I think many a times the municipal authority gets structural design based on a student version of a Stat Pro, which is, I really doubt. And I think, of course, we have the limit state and working states. I think our engineers have now missed out on doing manual design, and then we rely so much on the software. At the end of the design, when you implement the structure, you forget the IS code, there is not even space for the aggregates to go through. So my feeling is there is no economy, there is no structural economy for the client. And I think those kind of structure, basically from the structural point of view, provides a lot of rigidity, and I don't think over-info structures are good. So giving to that thought, I thought two things we need to do here. One is, I think we should ensure the basic parameters are there. That is, I think geotech surveys must be done. Even if you can't do a plate load test, I think at least SPT must be done so that the soil parameters can be there, C5 or whatever, shear and everything. And the other thing is, I think there should be some kind of analysis or comparison to make an assessment of, I don't think all the 700 structures with the very one or two structural engineers city you can't do, but perhaps we need to develop idea as to compare, because I think it's an economy law. We are actually, creating an abnormal economy here, and I think there's no economy of structure. So basically, probably, some of the recommendations that Sanjay has given here should follow the context issue. And I think right now, even those concepts of static and dynamics were never there. And I think this is really a time. And I think the more important fact is that we are lying in a zone 5. We are just waiting for an earthquake to happen. And I perhaps maybe with the Department of Disaster Management taking big initiatives, I suppose they are conducting studies to see how many buildings in Thimphu would withstand zone 5 sort of earthquake. These are really of paramount importance, and I think for the future our research should go in this direction, Mr. Shunila. Thank you.
Thank you, sir. Thank you for bringing out issues and also giving very practicable solutions, Sunila. A small corrections on the time allotted for the discussion. I actually forgot to take note that we started late, so instead of 3, I think we'll conclude this session at 3:20. So any more questions?
Thank you, moderator. My name is Seong Yutup, and I'm a lecturer at the College of Science and Technology. And would like to thank both the presenters for a very relevant and pertinent topic, safety on life and safety of the building. But my question is to Mr. Sanjay, and I have to say that I've really appreciated the work that he has done. And it's not a long time ago when engineers are really scared to hear the word dynamic analysis. And I think that's still the case. So probably that's the reason why they do not really dare to undertake that analysis in trying to analyze the building and in the design process. So maybe it's still the case that engineers are not really very comfortable with the term dynamic analysis. But nonetheless, Sanjay has dared to venture out, and I think that's very commendable on his part to attempt to analyze building besides the current norm that most engineers usually adopt. But my question, to be specific, is from his study, do you think if we have buildings with steps back, like vertical irregularities, so do you think the number of story, is there a threshold beyond which or below which there's no need for response spectrum or dynamic analysis and the equivalent static method would still be sufficient? Would the number of story had any impact on that? So if the building is more than a certain number of height, with that step back property, then there's no way that we have to undertake dynamic analysis. But if it's less than that, your normal equivalent static method would still suffice.
Thank you, sir, for your question. If the buildings have various foundation level in the sloping terrain, as per the code, it says that the building height should be from the base of the top of the foundation level to the top of the roof. So irrespective of whatever levels or whatever foundation levels the buildings are, if you use the static method, the height of the building should be from the base of the top of the foundation level to the top of the roof. that means even if there are multiple step backs, even if the foundation level is towards this side, the story height should be calculated from the top of the base of the top of the foundation level to the story. So in that case, I feel that even if we do the static analysis for various step back features, the design should be the same like for the regular structure. But if there are if the discontinuous shear walls are incorporated, like if we use the shear walls in the basement floor as a retaining wall and all, I have not conducted or analyzed at what story level this discontinuous shear wall will be safe. But as far as I think if we are not certain about conducting the dynamic analysis at all, we should better remove the shear walls in the basement floor and not incorporate at all. Because as we can see through the analysis, it says that it changes the dynamic behavior of the building when there is a discontinuous shear wall in the basement floor. Even regarding discontinuous shear wall and what maximum story it can go, I should say that I have not done. But even with the 6-story height building and the discontinuous shear wall, it is drastically changing the seismic behavior. When there is shear wall, it attracts more forces, and so the columns which are at the adjacent to these shear walls get affected more. So if we just conduct the static analysis, then we are giving unrealistic seismic response, and then we end up giving more reinforcement, or then we end up giving more detailing, like we have special confining zone and all, and we will end up giving more in where it's not required, and where it's required we will end up giving less, like under reinforced, and sometimes we end up giving over reinforced and all. I think I answered the question, sir.
Lasla, before going to next question, relating to what Sring Nidu mentioned about the dynamic analysis, maybe a point for thought, maybe in the meantime. It was said that engineers are not comfortable carrying out dynamic analysis. They have to dread. Does it mean that our buildings are at risk? So this is a question that maybe someone of you like to ponder upon. Maybe Sangi can pick it up and add on to some of the questions later on. So another question if anybody has.
I'm Pamala. I'm a conservation engineer. I work for the Department of Culture. My question is to Sir Sangela. Just as I see your slide, and then relating back to the construction that are happening around Thimphu, especially if you go towards the Babisa side, what I see is like since they are building it on the slope, Bengaladin, in Bhutan, the engineers, I don't think we consider the topographic amplification factor in our design. Given that aside, now in that areas, what we do is we see a huge shear wall which is built at the back of the wall level, especially to retain the soil structure. But what I've seen people doing here, like especially the engineers, is they design that as they just put the load on the beams as a dead load, and then they design level. But from my own engineering perspective, I think shear walls for a building has to be animable, equivalent. Like if you put it on the front line of the columns, it has to be at the back level. So any balance show over. But Bhutan maybe maybe. So I've seen you do some analysis. I think you use diaphragm and plate in that ETAPS level. So did you find any different response of the building? Can you just share your views? And then second thing about the dynamic analysis, from my personal point of view, if your building is regular up to 2 to 3 stories, I don't also recommend doing dynamic analysis because it's all dependent on the time series level. But if it's more than 6-7 stories, then it's important for doing dynamic analysis. That's my justification. Thank you.
Thank you, sir, for your question. From the structural point of view, what you have mentioned is right. If we want to be safe and do not want to take risks, the building should be very regular. And as you said, if the shear walls are at the back, it should be in the front also. That means it should be symmetric. But shear wall, I think there is a misconception, or like we structural engineers or designers they want to oversimplify their works. as far as structural concept is concerned, this shear wall should be able to optimize the response, and it should be able to perform well. But in our case, we use shear walls in the base so that we do not need to construct RCC retaining wall at the back or all. So we'll end up just putting the shear wall there, and then we perform static analysis, and then we end up doing like that. I think if we put the shear walls, then it is necessary that we have to perform the dynamic analysis. I have seen that when we put just shear walls in the backside of the building and then we perform the design, then it changes even through the time period and all. As per the revised 2016 IS 1893, it says that static method can be applied for buildings with time period less than 0.54 seconds. So if we do not have our own capacity, like for our architect engineering, we have no seismic hazard map of our own. If we have to rely on the codes, then I think it is better we perform the dynamic analysis and then adopt the results from that analysis. And regarding that second question, I forgot. Second question, I forgot.
I think you've answered more or less.
Nice. Oh, okay. Thank you, sir. Thank you. I got it. As per the code, it says that the static method, conventional static method, can be applied for buildings in seismic zone 2 with height less than 15 meters. So for buildings in seismic zone 3 and 4 and 5, I think it says that we have to perform dynamic analysis, whether the story is 2 or 3 or 4, 5, because the code says that static method may be applied for buildings with height less than 15 meters in seismic zone 2. So when our Bhutan is located in seismic zone 4 and 5, I think actually that dynamic analysis is not as scary as it sounds. When I didn't study this structural engineering, I thought, oh, this is very complex idea. Maybe only that capable expert can do that. But if we spend some more time and then do little research on how it is performed and what is the basic concept behind, I think everyone here can do that. It's not as scary or as difficult as it sounds. Just a little bit effort, and I think everybody can do here. Everybody here can do that.
Yes. Since no question is coming to Mr. Krishna, I would like to take this opportunity to actually highlight on some of the points CEO sir has mentioned. What's your view on factoring in the cost of OHS into the tender itself?
Thank you, moderator. Actually, like CEO sir has already mentioned, in our past two safety seminars, which was organized in collaboration with the Department of Roads, we are currently having a project, this technical cooperation project on construction and maintenance of bridges, where the experts are actually working to develop a checklist and a guideline to actually include such checklist as part of the tendering item. So, but of course, I think there's still a lot of long way to go, but I think it's one of the first steps. And from the government's perspective, that time I remember the previous Shapto Lembo also commented that we also need to look at the cost factor. But from the organization's perspective, I think it's from the contractor's perspective, I think it's really important and fair also for them to actually set the budget and an item for implementation, which includes OHS. I think that's all.
Yes, thank you. Any more questions?
My name is Satyanarayan. I am from India, from F1 Infrastructure Limited. I am from contractors organization, and we are dealing with the workers who come from very poor educational background, and implementation of OHS is actually very difficult. My question is to you, Mr. Krishna, is how to make a bulletproof system to ensure that the safety measures are implemented. As part of our organization, we have now started initiation of making it compulsory for each and every engineers to go through what we say online e-learning course, e-learning module conducted by DuPont. And also we have a system of selecting behavior-based safety supervisors who in turn select observers below them. And then those observers further select observers below them, thus creating a bigger crew of people who can manage, who can supervise the safety. Also, we have now initiated on sites, you can say 10 minutes housekeeping, engaging each and every people, right from the engineers to the workers, so that engagement is increased. So what is your views on how to create more and more engagement and ensure leadership for ensuring OHS implementation?
Thank you, sir. I'm afraid that there might not be one short sort of answer to your queries, but as you've already actually highlighted that I think your company has already taken so many adequate measures to actually address some of the issues towards OHS. But of course, what I highlighted in my presentation is you need to remember that especially on the 5S and then the PDCA, these are incremental steps. It's something that cannot be achieved at once. They have these construction companies who undertake the ODA projects. They have been, for example, in Bhutan we have DNC. They've been working for the last 40 years here and with zero record of fatalities. So of course, I think it's like I said, it's an incremental process, and the organization culture, the culture has to develop. But now coming to the maybe the other aspects, like I said, even Bhutan is facing the same things, because like Dasho also mentioned yesterday that from the 50,000 workers, almost 80% are migrant workers from India, and it's not assured that every time the same workers will come back. So no matter you train one batch, next time another batch comes, it's totally different set of people, so you're back to square one. But of course, I think the other thing is, what I mentioned is the hazard prediction activity. So that's very important. So for example, like you mentioned in your thing, you have the behavior-based supervisor system that you're inculcating in your organization. So I think these are some of the steps definitely that will help you in the long run. So your organization, as yours is a multi-billion-dollar organization, but the other thing that that may actually interest you and I can share definitely is the Heinrichs models. I think that is something that definitely changed my perspective on OHS, and I'm no means by any expert, because I'm also just an officer here. But that is something I think that you can really consider and take it forward. I think so. Heinrichs is the way to go. 1:229:300.
Reporting of near misses are actually very poor.
So
This needs to be strengthened.
Absolutely, sir. Like you really mentioned, sir. I think the responsibility of the safety supervisor, and then the accountability, and then the information sharing. That needs to be enhanced for actually implementing the Heinrichs models.
Thank you.
Some more questions? If not, I would like to pick up from a statement made by Sangye so that we can contemplate in the meantime. Sangye said that we are in Zone 5. We don't have seismic hazard map. Related to this, I also like to quote an incident when I was back in the office. More political kind of statement. What was being said was that all of these are assumptions. The maps are neither ours nor did our people made it. So the kind of questions, political questions kind of thing posed to us were, are we building on assumptions? Are we losing on cost, efficiency? So if you have something to throw on that, I think that also going to shed a lot of light. Because just now, like CEO sir and some mentioned that whenever when a structural engineer takes up the data for soil bearing capacity, I think it's generalized. They say that, oh, Mutithang, take it 100, Babisa, take it 90, 50 or something like that. So, are things happening on assumptions on a very critical part of constructions, which if things go wrong could be very, very risky for the lives of people. Some of you can also think along that line, and maybe this is an opportunity to ask Sangye about Tesla. So, any more questions?
Good afternoon. My name is Ugin Gelson. I work in CDCL. Since there are not many questions coming from the floor, I just took this opportunity. My question would be to Krishna sir. Every individual has an inspiration to look up to. Likewise, in CDCL, as the construction company, we are looked up to by the contractors in the country as the example setter in the country. So, CDCL as a construction company, we would like to set an example in complying with the OHS rules and regulations. So, I personally know that JICA has been really active in imparting this importance of OHS in the construction industry. And therefore, my question would be, how would JICA would like to assist CDCL in the OHS aspects? Thank you.
This is little of the syllabus, but I think because Krishna comes from JICA, I think you don't have to commit, maybe something.
Thank you, moderator. Thankfully, my chief is sitting right in the front row. With your permission, chief, I'd just like to say that, of course, Sir William sir, like you said, that the inspiration or basically the benchmark that CDCL has achieved. Again, I would like to congratulate you all. Been as pioneers, front runners towards the field of safety. I think in terms of actually, let me talk about what JICA is doing in Bhutan first towards construction safety. Of course, like Sir has already mentioned, that we have been actually calling forward engineers from the relevant organizations like the Department of Roads to actually learn from the contractors like DNC who are implementing the projects. This may be small steps, and when we received 2 engineers from CDCL, we were so happy. Our previous chief, we were so happy that actually CDCL has taken this step forward. So of course these are, like I said, very minute steps maybe that will go a long way in increasing the capacity of OHS. And the other aspect is like I said, we are doing small dissemination seminars, and we're trying to involve CST also to get a very neutral and independent research group. And if possible, we would like to take this collaboration forward. And now, just from starting this year, we have been fortunate enough to actually we'll be sending one officer from the Department of Labor in the Knowledge Co-Creation Program in JICA to enhance his capacity in OHS. To do with CDCL, I think it's different if we can discuss on different forums. If it's okay, Laza, you can say. Yeah, I think because there's so many things we could do, and the modalities and everything. I think if it's okay with you, I'd like to take the permission to discuss that. Thank you, sir.
So we have about 4 minutes to conclude the session. Yes. Yeah, sure.
For example, I'm Mong Chin Dojil. The OHS in general, I find this topic very tricky, because when you trigger down, it comes to PPE, personal protection equipments. Now, in general practice, what is happening around is if somebody is issued a boot, helmet, perhaps hand gloves, that suffices the requirement of PPE level. But if you look deeper into what PPE or personal protection equipment should be, it has to be designed. People working in industrial whether people working in the industry, manufacturing sector, mining, underground tunnel, construction. If you look in general, they wear same safety helmets, first and foremost, because when you talk about safety equipments, it has to be designed as per your environment. The other one is even the boots. Even if you go to any industries, construction, mining, you wear the same boots. So it may qualify as PPE given to a person, but if you look at your technicality, it may fail. Supposing when you order the hand gloves for your workers, you buy in bulk. So the operator, the hand length of the operator and the gloves sometimes may not match. By default, he has to wear those hand gloves, and then he goes into a workstation. Now, there is no guarantee that something cannot happen, because if the gloves are longer than his palm or finger size, then instead of doing better protection, it may lead to a very unfavorable or undesirable circumstances. So my question, or rather to Mr. Krishna, is if you could, from the JICA, Japan being this zero, that highly improved OHS system, if you all could designate so particular equipments for a particular kind of job,
we are supposed to conclude. So, is it something very different or in line with suggestion? Maybe, yeah. That's okay, Krishna. Yeah, you answered.
So thank you, sir, for your active participation in the past 2 days. I think, like you pointed out, PPE just by itself, like I also pointed out, it doesn't make any sense. Like you said, actually, different environments require specific PPE equipment, and that needs to be provided. And regarding the sizing, the typology of boots, and I think those are very important highlights that you mentioned. In Japanese construction companies, because they have actually included in the cost, they can afford to provide that. So unfortunately, I think in the Bhutanese context, most of them are not customized. So if that's okay, I'll just keep it at that. It's okay.
So maybe your 30-second suggestion.
Thank you, sir, for your lovely presentation, sir, about the OHS. So, but what I feel is that just providing safety equipments, setting out some rules and regulations, and a good environment doesn't ensure that there won't be any accidents in the sites. We also need to evaluate, because the laborers at Sir said they come from an uneducated background, sir. So it's very important that we evaluate what are their skills. We enhance them and we assign them the right kind of task also. Because if a person doesn't know how to drive, no matter how safe is the vehicle, accident will happen, sir. So that was my view, sir.
Okay, thank you, sir. I thought the session was very interactive. I was keeping a very close watch on the audience, except for one or two. I think most were very attentive, and personally I enjoyed a lot. I could relate to these topics very well because of the fact that I've been working as architect and also urban planner, urban designer. And I have a lot of questions to take away with, which I think later on with the colleagues I can discuss and thrash things out. So, assuming that all of you have enjoyed, a lot of important messages to take across, and a few questions that I threw upon, so that I think maybe it's important to think about that. And because these two subjects are very critical to the quality of life later part of the built environment, I think this was very relevant and very important. So with this, I would like to thank two presenters, and I would also like to thank all the audience for your participations. And with this, I would like to conclude this session. Thank you so much.